Force, Newton's first law of motion. The first law of motion states that an object continues to be in a state of rest or of uniform motion along a straight line unless acted upon by an unbalanced force. So in this case, an object is in a state of rest or of uniform motion are two parts of the law. An object in a state of rest, we consider it as one part of law. An object at uniform motion is considered as second part of law. And let us understand this law with a more meaningful example. Let us say we will take a book and we try to push it in a gentle manner. Then we find that the book does not move, no movement. Why? The gentle push is opposed by the equal and opposite force of friction. Now let us try to push the book with a stronger push. And it moves. Why? Push exceeds the opposing force of friction. Now we will see the same book is pushed with a constant speed on a straight line. The effect is it moves in a straight line. Why? The net force here is 0. At every point, the book is moving at the same speed. So at every point, the force of friction is equal to the push by the book. So it moves at the constant speed. And when you push harder, let us say we are pushing the book very hard. Then it moves and speed also changes. Why? It exceeds the force of friction. This explains how the book from its state of rest using a force which is higher than, which exceeds the opposing force of friction, then the book moves. Now let us see the first part of first law states that an object is at state of rest. So every object is associated with a certain state of rest. Otherwise, all the objects will be moving in this world. So this particular property is also termed as inertia. Until and unless you apply an external force on this object, it will not move. So let us see the definition of inertia. So inertia is that property of a body due to which it resists a change in its state of rest or of uniform motion. So we'll see the examples to understand the high inertia, low inertia, and what it requires to move it. So we'll understand from these examples. Let us take a heavy stone, compare it with that of a football. Football is bigger in size but lighter in weight compared to the stone. So the inertia is high in this case and inertia is low in this case. Now let's take another example wherein a cricket ball and a rubber ball of the same size. We understand that when we try to hit cricket ball, we require more push, and when we try to kick rubber ball, it requires lesser push, assuming both the balls are of the same size. So when we require more push, that means this ball is having higher inertia, whereas rubber ball has low inertia in comparison to the cricket ball. In the same manner, we can also say a toy car. A boy is pushing a toy car and a man is pushing a real car. As a toy car, it requires less force to push the toy car, whereas the real car requires a stronger push, so it has a high inertia. So these examples state that when the object is heavier, like stone, cricket ball, or real car, it requires a stronger push, heavier push, because its state of rest property, that is inertia, is high. Its resistance to change from its state of rest is higher. Whereas in the case of football, rubber ball, or toy car, you require a lesser push, hence a low inertia. It can be easily pushed or it can be easily changed from its state of rest with a lesser force. Another thing we understand from this is, in the case of stone, cricket ball, and real car, it's a more mass. So this gives rise to more mass. Even the real car is higher mass. The mass of the object is higher. Whereas in case of the football, rubber ball, and toy car, in comparison to the other objects, then it has less mass. Which states that inertia depends on mass of the object. And to overcome inertia, we need to apply force. So, we say that inertia depends on mass of the object, and to overcome inertia, we need to apply external force. Having understood the inertia, let us now see what the second part of the law says. In this case, body is in uniform motion. On applying external force on such bodies, it can either stop or change direction depending on the state in which it is in, or change speed. See with an example, a cyclist is pedaling a cycle and he stops pedaling a cycle which is in uniform motion. Then what happens to the cycle? The cycle stops. Why does it stop? Because by stopping pedaling, the cycle which is in uniform motion has changed its state from its uniform motion to stop, because there is no external force applied. By pedaling, we give external force to the cycle. Now there is no external force applied. The external force is removed. Let's see some everyday observations on first law, which includes inertia, which will give us a more insight into the first law of motion. When a tree is shaken vigorously, its fruits and leaves fall down. Why? Because the tree moves to and fro when you shake it, whereas the fruits and leaves tend to remain at its state of rest, so it falls. When a car or bus starts suddenly, what happens? We see it on an everyday basis. What happens to its passengers? Bus starts and passengers? The passengers fall backward. Why? Due to inertia, the passengers tend to remain in state of rest, because when the car or a bus is moving, passengers are actually sitting inside stationary. But when the bus stops suddenly, then the passengers who are tending to remain in state of rest. So that sudden movement, external force applied on them, makes them change their position. So they go backward due to inertia. When a running car stops, what happens? The car stops. But what happens to the passengers? They are still in a state of rest. So they fall forward. Again, due to inertia. These are all the daily, everyday observations that we see in our lives. When a car takes a sharp turn, what happens to the passengers? The car will be moving, takes a sharp turn, but it is still moving. Then the passengers fall sideways. In all these cases, the passengers are in a state of rest. So when there is a sudden application of force, either car stopping or a sharp turn, things like that, when it stops, they fall forward. When it takes a turn, they fall sideways. So all these changes of the passenger state happens because of the external force that is applied at various stages. So this gives rise to an understanding of the Newton's first law, which says that when an external force is applied, there will be a change of state, either from its position of rest or from its position of uniform motion. Hence, the Newton's first law of motion provides us the definition of force. As force is that which changes or tends to change the state of rest or of uniform motion of a body. Or we can say force can produce either acceleration or retardation. Due to the external force, the first law states the body's state of rest or state of uniform motion changes. So when it changes, then it creates a change in speed. When it creates a change in speed, then there will be an acceleration or retardation. So based on whether the car is increasing or decreasing its motion. Therefore, force is a vector quantity as it is depending on acceleration, which is a vector quantity with magnitude and direction.